So let us solve a problem applying Ohm's law and series parallel combination of resistors. Question is, in the following circuit, determine the equivalent resistance and current through each branch. Also determine the total power drawn from the supply. So circuit is given. We have to calculate the equivalent resistance of this circuit, then current flowing through each branch, and the power drawn from the supply. Okay. So first of all, let us calculate the equivalent resistance. So see, so here there is a 10 ohm resistor. It is connected in series with a parallel combination of two 20 ohm resistors, which is again connected in series with a 5 ohm resistor. So first of all, let us calculate the equivalent of these 20 ohm resistors connected in parallel. Equivalent resistance of two 20 ohm resistors connected in parallel. So we know if two resistors are connected in parallel, their equivalent resistance can be calculated as R1 R2 divided by R1 plus R2. So equivalent of 20 parallel 20 equals R1 R2 divided by R1 plus R2, which is equal to 20 into 20 divided by 20 plus 20, that is 400 divided by 40, which is equal to 10 ohm. So equivalent resistance of the parallel combination of these two resistors will be 10 ohm. So the circuit, the resistance portion of the circuit can be redrawn like this. So there is a 10 ohm resistor, then these two parallel 20 ohm resistors can be replaced by its equivalent resistance 10 ohm. So again 10 ohm and a 5 ohm resistor. Okay. So this will be the resulting circuit. So here we have three resistors connected in series. So we know how to calculate the equivalent resistance. So equivalent resistance will be the sum of individual resistances for a series circuit. So equivalent resistance will be 10 plus 10 plus 5, that is 25 ohm. So equivalent resistance of this particular circuit is 25 ohm. So now we have to calculate the current through each branch. So here a current will flow through this path up to this 10 ohm resistor, and at this point the current will divide into two. So let us mark it as I1 and I2. Okay. So then they will flow through these two resistors, and at this point these two currents again adds up, and the total current I will flow through the 5 ohm resistor. So we have to calculate current through each branch. That means we have to calculate this total current I, this I1 and this I2. Okay. So according to Ohm's law, we know that I is equal to V divided by R. So total current drawn from this voltage source, or total current flowing through this circuit, will be equal to total voltage applied across the circuit divided by total resistance of the circuit, or equivalent resistance of the circuit. Okay. Now the voltage applied across the circuit is 250 volt. So 250 divided by equivalent resistance, we have calculated it as 25 ohm. So 250 divided by 25, we will get the value of total current as 10 ampere. So total current, this current will be 10 ampere. Now we have to calculate I1 and I2. So see, I1. So I1 is the current flowing through this 20 ohm resistor. Okay. So now how can we calculate this I1? So we know that here this 10 ohm resistor is connected in series with the parallel combination of these two resistors, and again that is connected in series with this 5 ohm resistor. So this 250 volt divides into 2 and appears across all these resistors. So we can calculate the voltages across each of the resistors. As we know the current, we can calculate the voltage, or otherwise I1 and I2 can be calculated using current division rule. So let us apply current division rule here. So I is the total current, and at this point I divides into 2. So let us calculate I1 and I2 using current division rule. Apply current division rule. Then I1 will be equal to, the equation for current division is current is equal to, current through a particular branch is equal to total current into opposite branch resistance. Here we are calculating I1, so the opposite branch is this one and the resistance is 20 ohm. So total current into opposite branch resistance divided by sum of resistances, that is 20 plus 20. Total current I is 10 ampere, so 10 into 20 divided by 20 plus 20, that is 200 divided by 40. Sorry, 40. So what will be the value? 5 ampere. So I1 will be 5 ampere, and similarly I2. So let us calculate I2. I2 is equal to total current into opposite branch resistance. So we are calculating I2. So opposite branch is this one, resistance is 20 divided by sum of resistances, 20 plus 20. So same as this case. So answer will become 5 ampere. So we have calculated the current flowing through all the branches in this particular circuit. Total current is 10 ampere, this current is 5 ampere, and this current I2 is 5 ampere. So now we have to calculate the total power drawn from the supply. So we have to calculate the total power drawn from the supply. And we know the equation for power. Power is equal to I square into R. Okay, that is one equation for power. Otherwise we can calculate power as V into I, voltage into current. So total power drawn from the supply will be total current square into total resistance of the circuit. So total current is 10 ampere. So 10 square into R, total resistance of the circuit or equivalent resistance, that is 25 ohm. So 100 into 25, we will get 2500 watts. Or if we use the equation V into I, the total supply voltage is 250 into total current drawn is 10 ampere. So answer will be 2500 watt.